All right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still going over our understanding of the visual transformers module. Let's have a look at what we went over today. Now, actually, we did get around to implementing a new piece of code. Well, it's not an actual piece of code that we're going to be. Well, it is code. It's code that we're going to be using to actually help us get a handle on the practical use cases of what we're going to be doing in this module, the visual transformers. So let's take it from the top and see exactly what we're working with. So as you recall, yesterday we were working with our embeddings. So let's start from there. Now with the embedding layer, what we'll be able to get will be another tensor, which is like this. So this is the new tensor we would get after we go through the procedure of getting our embedded layer set up and getting everything configured. This will be our new shape that we have here, the 1 by 256 by 768. Now remember, the 256 is our patch size, and the 768 will be our pixel count. So as we will see, it takes the indices and then turns them into dense vectors, which we're interested in. Now let's look at an example that we can test out with some live code. So you see here we have model equals tf.caress.sequential. We have model.add tf.caress.layers.embedding. And then we have our embedding shape of 1000 by 64 by input length equals 10. The model will take as input an integer matrix of size, batch, input length, and the largest integer, i.e. word index, and the input should be no larger than 999 vocabulary size. Now, model.output shape is none 1064, where none is the batch dimension. Then we have our input array here, as you can see here. Let me go back down, I went too far. We have our input array equals np.random.randint 1000, size equals 32 by 10. We have our model.compile, RMS prop. Then we have MSE. RMS prop, I'm assuming, if I recall, RMS will be the root mean squared, probably a probability. And then we have the mean squared error. I'm assuming if my memory serves me correct, these are what these stand for. We have the root mean squared probability, and then we have the mean squared error. Then we have our output array equals model.predict. Our model is going to predict the input array, and then we're going to print out our model.output array. That's going to be printing out the variable that's stored in our output array, and that should be the model that was predicted, or that should be the prediction of our model of the input array. That's going to be getting printed out here. Now, since we are working with integers, we have no need for the vocabulary, so we'll use number of patches instead. Let me show you what we're talking about with that really quickly. So this was set up for maybe an NLP. So you can see here is not to exceed 999 vocabulary size, but since we're not using text or strings, this doesn't pertain to us because we're going to be using number of patches, so we're strictly using integers. So that's why I put the little note there just to let us know what's going on. So if we're dealing with NLP, natural language processor, vocabulary would be our focus, like I said. But since we're not using NLP, we're not focusing on vocab. Now we can print out our new shape to see what we have from this new input. And we're going to do print output array. I have it twice. I don't know why I have it twice. I could delete it here. So basically that's what we did this morning. We took a little bit of notes, but I was mostly focused on this little text, not little text, this little test code here that we have here. So once we're going to get and get this run and compiled overnight so we can see exactly what's going on and we can get a better understanding of what we're going to be doing inside of this module, the visual transformers. But yeah, but of course I will keep you posted every step of the way. I'm going to run this overnight and we'll have some answers by the morning so we can dive a little bit deeper and see exactly what we're going to be doing. But like I said, I will keep you posted every step of the way. For now, this is the Python Papi. You guys stay Gucci.